Hello, welcome to day 5. Our learning target today is I can solve quadratic equations by inverse operations, meaning we're going to use our square roots. So as a warm-up, I would like you to solve method 1 and 2. Practice solving by factoring and practice solving by graphing. Pause the video to do that in your notes, and then unpause to check your solutions before I intro inverse operations. Okay, so for the first one, we should have gotten the solutions x equals -5 and 5 using the difference of squares pattern. For the next quadratic solved by graphing, I typed it into Desmos and got my x-intercepts of -1.5 and 4. I also wanted to know, because those are rational solutions and exact, I could have also factored. I didn't expect you to do that, but you could have also factored it to 2x plus 1 times x minus 4 equals 0, and we would have gotten the same solutions. So the next method is called inverse operations, which should sound familiar. And it's the idea that we want to isolate x. Okay? And so our goal here, okay, and normally if we were solving an equation like 4x equals 9, we would divide by 4 and get x equals 9/4. But notice we're solving a quadratic, which is not the same. And so while we could easily isolate x squared, we're going to have to do a little extra step to isolate x. Okay, so what we're going to do is, what's the inverse operation of squaring something? That's taking the square root. So we're going to take the square root of both sides. So x equals, and the important piece is remembering that when we take the square root of a quadratic, we have two solutions, and we get those two solutions by adding a plus or a minus sign. Okay, and we'll go more in depth than this before, but I have square root of 9 over square root of 4. Square root of 9 is 3. Square root of 4 is 2. So by using inverse operations, notice that's 2 steps. I can get my two solutions, and this is the same thing as saying x equals a positive 3/2 and a negative 3/2. So in the following videos, we're going to explore how to solve all these different problems with inverse operations. Okay, so the important piece too is first understanding when should I use factoring, when should I use graphing, okay, and when should I use inverse operations. So what I first want us to do on these 3 examples is I want you to solve by factoring and solve by graphing. Okay, again, notice it says use our calc table. We're just going to say use Desmos, sketch a graph, okay, and then list our solution. So I want you to pause the video, and I want you to solve by factoring and graphing these 3 problems, and unpause when you're done. Okay, so for problem 1, we should have factored using the difference of squares and gotten x equals -2 and 2. On the graph, I would have x-intercepts at -2 and 2. For number 2, I would have factored x minus 2 times x minus 2, and I would have written x equals 2, 2. Make sure you write it twice because it's a double root. On a graph, remember we see double roots by having the vertex on the x-axis. So you would have seen a similar graph to what I sketched there. Again, 2 solutions, because remember quadratics always have 2 solutions. For example 3, x squared minus 12 equals 0. I can graph it. Well, first of all, I can't factor it, right? Because there's no 2 numbers that multiply to -12 and sum to 0. Because 12 is also not a perfect square, so I couldn't use the difference of squares pattern. So factoring definitely does not work. Graphing works, right? We get x equals -3.64 and positive 3.64. Now the difference is it's an approximate solution, right? So our big idea is how can I solve to get exact solutions? And that's why we're going to have inverse operations, okay? So if you look at example 1, sometimes we can solve quadratics easily by factoring or graphing, such as in warm-up number 1. Number 2, sometimes quadratic equations give us one real root or one real solution, also known as a double root. Again, we can solve it by factoring or graphing and easily get our solution, and that's warm up 2. And example 3 is the big kahuna as to the why behind this lesson, right? So we can't factor and or get exact solutions. Because again, while approximate solutions are great, we're not going to write our final answers like that. So sometimes we can't factor or get exact solutions. You know, it makes us a little sad. And so that's why we're going to need method 3 and 4, the first one being inverse operations, to help us get exact solutions. So watch the next video and I'll walk you through some examples on how to solve those.